All right, so let's just briefly look at 1 through 18. All right, and see what you guys are thinking as far as if there is an issue. Anybody? Want me to explain one? Tell me. No, that's false. Through any 3 points, what if the 3 points are on the same line? Right, in order to make this true, it should say through any 3 non-collinear, right? Non-collinear points. There would be 1 point. All right.
If all points are non-theorem, then how can they be plane?
I didn't hear you.
If all points like have a line in between them, then how do we have planes if there's
Who told you that?
you have us just like drawing like the invisible lines, right?
So here's what you're thinking about. Do these 3 points that are on this line form a plane?
No.
No, they don't. That's why it's false. If I put another point over here with these 2 points, that makes a plane. It makes a plane because, right, they're non-collinear. A line does not make a plane. A line does not make a plane. Maren. No. 11. All right. If AB equals BC, then B is the midpoint of AC. How is that false?
I thought it was true.
I know, it's not true though. All right. AB AB and BC. AB is equal to BC,
Mhm.
right? Is B the midpoint?
No.
No, that's why it's false. That's why it's hard, all right? Because you got to think of all the different possibilities. All right, you got to think of all the different possibilities. All right. Yes, James. Let's look at number 9. The reflexive property states that if A equals B, then B equals A. That is definitely false. That's a what? Symmetric property. Right? Reflexive is if A or A A is equal to A always. You with me? That's the reflexive property. Yes.
On 13.
If 2 lines do not intersect, they are parallel. That's most definitely what? False. Right?
But don't lines they keep going and make it in.
What does skew mean to you? Skew are 2 lines that don't intersect. The thing is, you're mistaken here is this. If 2 lines in a plane, if 2 lines are in the same plane and they don't intersect, they're parallel.
Okay.
You with me? These are the details I'm just telling you. I'm just making you aware of. They're so easy to make mistakes. All right. They're so easy to make mistakes. All right. That's why you have to have a good understanding. Yes. If a line is perpendicular to one of 2 parallel lines, then it's perpendicular to the other. That seems like that should be true also, right? But what if I drew these 2 parallel lines like this, and I drew a perpendicular line this way, right? That's not on that plane. Is everybody with me? Right, I can draw like, okay, so look right up here. So my pen here goes this way. The 2 parallel lines are this way, right? So this line is perpendicular to this line without being on the other line, right? Now, if all 3 lines were in the same plane, that would then be what? That would then be true. All right. So again, that's what I'm saying. Does everybody realize it's just hard to see all possible things? All right, go ahead, Mary. 2 lines are perpendicular if their slopes are reciprocals.
They have to be negative.
Yes, well. All right. Now that one really is from the next lesson, though. We stopped one short, I think, from last year, so that's why that one's there. All right, anybody else on 1 through 18? Those are sneaky, very tricky.
I still don't understand number 18.
Well, last year in algebra, we talked about writing the equations of perpendicular lines, and slopes were negative reciprocals, right? So if I draw this line right here, and I'm going to draw this perpendicular, what's true about their slopes? They're negative reciprocals. So in order for two lines to be perpendicular, their slopes have to be negative reciprocals. You with me on that? That's just a fact, okay? That's just a fact. Okay, flipping the page. 19 I thought was kind of fun. All right, you just have to mess around. All right. Now, what you have to understand also is you have to me, highlight the ones that are parallel, right? Now, notice parallel, parallel, and also parallel and parallel. So what's true about all of those lines? They're all parallel. All of those lines are parallel. So all the corresponding angles are going to be what? Congruent. All the alternate interiors are congruent, and so on and so forth. All right, what?
Why is J not 108?
Oh, it is. It is 108. All right, I'm sorry. It is 108. Thank you. 108. What?
Why is Q 116?
Well, here's an angle here, and here's an angle here. Those are alternate exterior angles.
Why is K 108?
Because they're corresponding angles. K corresponds to I, corresponds to G, corresponds to that. Those are all the same because they're corresponding angles. You see that now?
Yes. And how come epsilon corresponding?
Because it's not on the top right side of the parallel line. F is 72 because it's supplementary to 108. Right? Yes or no? Come on, kiddo. I want to help you. You good or not?
Yes.
All right. Anybody else on that figure? Kind of tricky. All right, now honestly, I feel like the next figures are kind of easy. All right, if you remember the rule I told you, if they're acute, they're equal, acute obtuse, they add up to 180. All right. So I'm looking at 20 and 21. I don't know that we need to do that much work.
On 21, how do you tell what's interior and what's exterior?
Interior is inside the parallel lines.
I know, but like, can you use the far left parallel line and the far right parallel line, or does it have to be-
Yes, because why? Because they're all parallel. All three lines are parallel.
Okay.
Do you see what I'm saying, right?
So it would have to be like that. You could say that 3y is exterior if you're just doing this.
Yeah, 3y. Okay. So look. 3y is exterior if you eliminate that.
Okay.
But 3y, if you don't, could also be in the interior of the other two. I understand what you're saying. Do you understand what I'm saying? Right? In relationship now, 3y is a what?
Interior.
Yes. It's just what parallel lines are you using when you ask me that question? You understand what I'm saying?
Yeah.
Right. So sometimes on my tests, I used to literally just put my hand over something so I couldn't see.
Okay.
Right. It messes me up. I know that's what's happening. That's why they do that. Right. On the SATs, they don't just put two lines in a transversal. That's what we did in 6th grade. There was just 2 lines and a transversal. Now they're going to mess you up by trying to add some extra lines in there. Correct? But I still say the safest bet is to say acute and obtuse add up to 180. So I'm looking at 5y minus 4, that's obtuse. I'm looking at 3y, that's acute. So they have to add up to 180. Right?
Right.
Okay. All right. Now, again, I tried to draw a few things just because some of them I thought were a little bit trickier, but again, some of you are better at it than others. Generally on the test, honestly, I just really just copy and paste. Or like 22 might be on the test. The exact same proof. I think that's fair. All right. I'm not saying it will be. I'm just saying a lot of times I just put the same proofs on the test that were on the review or from the work that we did during the week. All right. So is everybody okay with number 22? Go ahead.
I'm kind of confused on how to do it.
Okay. So honestly, and I'm trying to help you, but that's really not much help to me. Right? Like I would like you to say, I don't know why step A is given. I don't know why step B is definition of congruent.
I don't get B and C.
Oh, so we went from congruent to equal. That's the only difference.
Okay.
So that's the definition of congruence, right?
Yeah.
Right?
Yeah.
And then are you okay with C? AB is equal to BC and DE is equal to EF. That's just the definition of midpoint,
Okay.
right?
Yeah.
And then my arrows, I just tried to show you what I was substituting in. All right, that's all. What?
Why you have to do 2 substitutions? Why can't you just do the first substitution as BC equals EF?
Well, because that's not how they did it. Right. I understand what you're saying. I'm not arguing. You see what I'm saying? But I like doing my own proofs.
If I was doing my own proof, can I do?
Yes, but unfortunately, that's not the way this is.
Can I do the first substitution as BC equals?
Yes.
Yeah.
Yeah, I know what you're trying to say. All right. No, listen to me. You understand what I'm saying, right?
Yeah.
You have to justify from C to D,
Okay.
right? That's a substitution. I'm agreeing with you. I think you could do it differently. Right. I just, it's written out for a reason like that. All right. This is early when you don't have control over the statements. All right. What?
For B, because you're changing it to an equal sign, I thought it would be definition of equality.
I can't help that.
So how do you know when?
It's
to change it?
always definition of congruence.
But what if you're changing?
I
it
don't
to a
care.
congruent
I already
sign?
told you that over and over. It doesn't matter. I said, I think it should be different. But every geometry book I say, if you're going from equal to congruent or congruent to equal, it's always definition of congruence. Always.
Okay. And then also for C, just how do you know to like put that after AB equals DE?
Well, because I'm using what's given. B is the midpoint. So if B is the midpoint, the 2 parts are equal. Right? As soon as you say midpoint, you know that 2 lengths are going to be equal. You have to write that. All right, let's look at 23. Now, as soon as they said Q is the midpoint of PR and R is the midpoint of QS, I knew everything was equal, right? But of course, we had to show why that's true.
Why is 5 transitive?
Well, you can say what if you want. What could you say?
Substitution?
Yeah. Remember, we talked about that. I don't care if you don't, but transitive property, remember, is in the right order, right? PQ, look, PQ to QR, QR to RS, that's the transitive property. Agreed?
How do you know it's in the right order now?
Because the transitive property says in this order, the transitive property is if X equals Y and Y equals Z. What I mean by the right order is these are next to each other, then X has to equal Z. But you could just say, well, Y equals Z, so I'm just substituting Y for Z. And it'll be the same thing, right? I don't care if you put transitive or if you put substitution. I said I don't care. What? Well, segment addition postulates. That's what SAP is, segment addition postulate. Okay, so look right here. I appreciate that. Look right here. Look at these two things. And these two things. What did I do? I just added them. QR and PQ added together. RS is added. Uh-oh, maybe I did make a mistake on that. What two things? No, I'm adding these two, I'm sorry. PQ plus QR. I'm adding 2 and 4. Sorry. Not 4 and 5. Look at that, please. Do you see what I'm saying? PQ plus QR. You're adding equals, right? QR and RS. Does that make sense? Yeah, it's hard to see. I'm agreeing with you. That's why I don't mind. This can be done completely different too. All right, completely different. All right, but what I should have drawn that figure in there. And you're just adding equals. Okay. Yes.
I don't understand what segment addition postulate is.
Segment addition postulate just says if you have a segment, A, B, C, AB plus BC equals AC. That's all it means, right? Kind of like the angle addition postulate. It's the same principle. The two parts equal the whole. That's what some geometry books say. The sum of the parts is equal to the whole. Right? All right. Flip the page. Now, number 24. Yeah.
And I'm at number 3.
So angles that are complementary to the same angle are always congruent.
That's like the reason.
Mhm. There's a theorem that they want you to remember. It's called the Complement Theorem or something.
So we would just write on.
Yeah, I mean, that's what I don't see. I don't know the names of all the theorems. I just write out the explanation.
Okay.
And that way I know I'm correct. I don't have to name the theorem. Do you know what I mean? Now, if you're not sure about that, here's what I'm trying to tell you. That if this is 30 degrees, look up here just so I can show you something. If this is 30 degrees, then this would be 60, right?
Right.
Which would force this to be 30. So therefore, these two angles have to be equal. Correct. I used to do it. I don't really like that theorem as much, but they're trying to use it more. I would just add these two and add these two and then subtract this.
Yeah.
Right, that's how I would do the problem. Completely different. All right, but they wanted to use that particular theorem. I don't really particularly care for that theorem too much. I think it's harder to see, actually. Right, what?
So on the test, I don't care if we just write out our explanation instead of writing the theorem.
What? Say that again?
on the test for like the reasons, you don't care if we write out like.
No, that's what I just did. No, I don't care. I don't. I would expect most of you to write it out. Right? Memorizing the names of all the theorems is tricky, in my opinion. Right? Just tell me. If you know the theorem, that's fine. Right? All right. 25 was kind of the same. All right, what?
For B, could I just put AB plus BC equals 90 degrees?
Say that again.
For B, for statements, could I put AB plus BC equals 90 degrees?
AB is not an angle.
I know, so, oh, yeah.
Just change it to ABC.
Mhm.
All right. Let's move on. Now, how do we know like 26? How do I know that AB is parallel to DC? Because if lines are parallel, then their alternate interior angles are congruent, correct? If alternate interior angles are congruent, then the what? Lines are parallel. All right. This right here is referred to as the converse of alternate interior angle theorem. Would I expect you to know that? Do I care? No, you don't have to write the converse of the alternate interior angle theorem. To me, it's easier just to say if alternate interior angles are congruent, then the lines are parallel. Everybody with me on that? All right, let's slide down to 27. Bless you, bless you.
Okay.
What are we thinking here, guys? Yeah,
I don't think 4 and 6. Those are the reasons.
what is my reason?
If corresponding angles are congruent, then there's a,
You don't understand corresponding angles?
no, I do. So basically, whenever it says the two lines are parallel, it just means that the angle is congruent.
Yes. Alternate interior angles, you want to try to prove alternate exterior angles. There's lots of ways to prove lines are congruent. What?
I don't know what VAT is.
What? What are they? What is angle 13 and angle 15? What are those called? What is 13 and 15 called? Yes. Why are they congruent and what are they called? Why are they congruent? No, man, you're in a lot of trouble for tomorrow. Seriously. Help him. Vertical angles. They're definitely not corresponding, right? Agreed? Do I need to review with you corresponding, alternate interior, alternate exterior? You sure? All right, buddy. Anybody else? Yeah.
For number 3, for reasons, instead of substitution, could you just put that, their corresponding angles?
We don't know the lines are parallel.
Okay.
All right, if you don't know the lines are parallel, you can't say they're congruent. Everybody okay with that? Now, these I thought should be pretty easy for you guys. It's just determining if they're equal or supplementary or complementary or things of that nature. Does anybody have any questions with 28 through 31? What?
Wouldn't for 29, angle 4 be 31?
Is that right?
I got 31.
Yeah, 36 minus 5 is 31. Brilliant. And the other one would be 59. Yes, sir.
Why is X 18? Wouldn't you like? Wait, no. Figure it out.
I'm trying to show you on that. You can just divide by 6 to make it easier. Right. Anybody else? SAT problems, ACT problems now, a couple of those, 32 and 33. What?
Can you go over 32?
What are the angles of a triangle add up to?
180.
Right?
How do you know that and 65?
Are they parallel lines?
I don't know.
Well, in order to understand if they're parallel, you have to read the problem. Are they parallel?
Yes.
So, do you know why they're 65 now? That is correct. Easy as that. Let's go down real quick to the, well, we can, since it's the last one. What?
You go over 33. Sorry.
Don't they add up to 180?
Mm-hmm.
And what's the angle of the smaller? What's the measure of the smaller angle?
Oh. I didn't use that first one.
Yeah, that's what I'm saying. You got to read carefully, right? I'm not trying to be funny. That's the biggest problem. You solve the problem, they don't answer the question. On the test, geometry, that's the biggest complaint. I knew how to do it. I just didn't answer the right question. I can't help that. Please, you got to remember, you have to read, especially the ACT and SAT questions. All right. So here we go. 34, I didn't think was so bad. Yes, Olivia.
Could that be substitution?
Again, I'm agreeing. I'm not sure what you're substituting though. What are you substituting? I'm looking at this right here and this right here.
And then you're just adding.
You're just adding them.
Okay.
You see that now, right?
Yes.
Yeah.
Just by number 5. Property.
I added 2 and 4. Right? Somebody else? All right, here we go. Now, these are just understanding the notations, in my opinion. Anybody want me to say anything? Go ahead.
For 37, could I put if something is 36 inches? Then,
Yeah, I don't, something is a length though. Right, I'm not gonna be picky, but you just have to be careful of your description. You're measuring something, right?
Yeah.
All right, I'm not picky. I just want to make sure that you know how to write all the different forms. Yes, sir.
Well, for question 36, if it's or, doesn't that mean it has to be true?
Or does not mean it has to be true. I don't know what that means. An or statement is true if one or both of the statements is true.
Okay.
Somebody else? Go.
on 38, why, when it says write a biconditional statement, if possible, why wouldn't it be possible?
Because it's converse doesn't have to be true.
So it's converse isn't true, you can't write a biconditional.
That's true.
Mm.
You write a biconditional if the conditional and the converse are both true. You can write it as an if and only if. (41) through 50. Anybody have any issues with those?
Maybe 46.
Why is that false?
Um,
Only vertical angles can be congruent.
no.
You see what I mean?
Yeah.
Right, they don't have to be vertical to be congruent.
So is it inferring that they have to be congruent if they're vertical? Because I just thought that if it,
Now, if you did the converse of that, if two angles are vertical, then they are congruent. That is always true.
that's what I.
You see what I'm saying, right?
Okay,
But just because angles are congruent doesn't make them vertical, right?
right.
Think of corresponding angles. They're not vertical, they're congruent.
On the test, do we need to give a counterexample if it's false?
Yes. Here I should have written x equals what? X equals -5. Then over here you could say 1 point whatever 2. If two lines intersect, then they form right angles. If two angles are congruent, just write corresponding angles is fine with me. If two lines do not intersect, then they are parallel. Skew. If red and white paint add together to make blue. Is that true? Do red and white make blue? No. So that's what we were talking about earlier. That vacuous truth, is that what you called it? Yeah. Right. Oh, wait a minute. So that is what?
True.
That's true. Thank you. I wrote F. We know that's true. What?
Why is 40 true?
What does regular mean?
I don't know.
Well, you just have to look up regular. Regular means all sides and angles are congruent. Yes, sir.
How is 50 false?
If I make an A on my test in geometry, then we'll make an A in geometry. Just because you've made an A, you're going to make an A in the class. If you make an A on all your tests, does that guarantee you're gonna make an A in the class? Well, if you did your homework, right? You didn't fail all your quizzes. There's more to a grade than the test, right? Okay. Now, again, we still have some time, so if anybody's flipping through and they want a better explanation, I don't mind. Harrison,
Well, where do you find like the inverse contrapositive, all these definitions?
well, it's in section 1 or 2.3, I think. But if P then Q, that's the conditional. Converse is if Q then R. Inverse is if not P then not Q. Contrapositive is a combination. If not Q, then not P. That's the converse, the inverse, and the contrapositive. Remember, the contrapositive is always true if the conditional is true. And by the way, that is the conditional. That was a good question. Anybody else want me to try to explain something? James, you all right? Maren?
On number 25, why would D be that?
D?
Yeah.
Well, because that's what the angle addition postulate says. The sum of the parts is equal to the whole. Angle 1 plus angle 2 is equal to ABC.
Who would also be substitution in that?
Where do you see an angle 1 or an angle 2 that I could substitute in?
Yeah.
What?
You go to the definition of midpoint.
Yeah, if B is between A and C, AB equals BC.
I thought that was set.
What?
I thought that was set.
I can't help that. Segment addition postulate says the two parts equal the whole. AB plus BC equals AC. The midpoint is saying that if B is between A and C, AB must equal BC. Right? Segment addition postulate is when you're adding the two segments to equal the whole segment. All right, midpoint's telling you that those segments are equal. Agreed? All right. The end. That was a great job today, guys. All right, so we will end.